Hey guys, I wanted to go through just some general overviews of stoichiometry and then also do a couple of examples that might help you on the worksheet that you're going to get today. So stoichiometry, and I know you guys watched a little instructional video that I posted earlier, but stoichiometry is used to make predictions of either amount of reactants or amount of products needed or that could be produced in a given reaction. So it really uses that ratio that we see in balanced equations. So for example, when we look at a balanced equation, we remember those coefficients in front of the balanced equation show us what we can expect either produced or the ratio of those reactants, and these really represent, we could say that this coefficient represents the number of moles. So we could say, for example, that 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of water. We could also say, 2 molecules of hydrogen gas react with 1 molecule of oxygen to produce 2 molecules of water. But for now, let's concentrate on that molar ratio. So therefore, from this balanced equation, we can pull some conversion factors, okay? So remember, conversion factors are equalities, like 12 eggs are in 1 dozen eggs. You worked a lot with how many grams are in 1 mole of a particular substance. That's an equality, and so we can use that as a conversion factor. So in this example, so from this balanced equation, we can see that we really have, for 2 moles of hydrogen will react with 1 mole of oxygen. So we see that right here. 2 moles of hydrogen react with 1 mole of oxygen in this balanced equation. So we can use that as a conversion factor. We could also say 2 moles of hydrogen with enough oxygen will produce 2 moles of water. We can see that right here. The other equation we can get, or the other conversion factor that we can get from this, is 1 mole of oxygen, when it reacts with enough hydrogen, will produce 2 moles of water. So these are the 3 conversion factors that we can get from this balanced equation. This represents all the possible molar ratios for this equation. On the worksheet you're going to get today, you're going to have, it's a double replacement reaction at the top of the sheet that will have 2 reactants and 2 products. You should be able to get 6 of these ratios, okay? 6 of these conversion factors from that. So because we know this, we can use these to make some predictions, right? So for example, if I have 35 moles of oxygen, how many moles of water could be produced from that? So if we set up the equation, we start with, of course, 35 moles of oxygen, and we know we want to get to moles of water. So I choose one of those conversion factors that I took from my balanced equation, and there's only one conversion factor that will go from moles of oxygen to moles of water. So moles of oxygen to moles of water. I have to flip this because remember, what I want to get rid of goes on the bottom, what I want to keep goes on top. So I need to flip this the other way, but remember, since they're equalities, we can do that. Now I can see that moles of oxygen is going to cancel out. I'm going to be left with moles of hydrogen. It becomes very important in stoichiometry that we label everything. And some of you are really good about that. Some of you are a little bit sloppy because I think you just think, well, I know what I'm talking about and I'll remember. But you won't. This is going to get really, really dicey if you're not really labeling your things. So I'm going to label mole, not just moles, but moles of oxygen, because stoichiometry, the beauty of it is it allows us to go from moles or even grams of one substance in an equation to moles or grams of another substance in that same reaction. So if you get sloppy with your labeling, you're not going to see how nicely these things cancel out. Moles of oxygen cancels out. This is what I'm left with. You just have to be super organized and very, very diligent in labeling those things. So another example, again, this is very much like the one that we just did. So how many moles of oxygen will be needed if I have 7.25 moles of hydrogen? So, oops, I didn't put an answer in. So 7.25 moles of hydrogen is what we're starting with. My conversion factor, I need a conversion factor that's going to get me to moles of oxygen from moles of hydrogen. Again, there's only one conversion factor, and I just flip it and use it whichever way I want, because remember, you just got to think what I want to end up with is going to go on top. So I just have to, I want moles of hydrogen to go away. I want to end up with moles of oxygen, so that goes on top. Again, I'm using this ratio that came directly from my balance equation. My balance equation says it's 2 moles of hydrogen for every 1 mole of oxygen. And that gives us, if I solve for the problem, excuse me, 7.25 moles of hydrogen times 1, and then I take that answer divided by 2, 3.63 moles of oxygen gas. You will notice that everything has to go through moles. The only way I can get from hydrogen to oxygen or hydrogen to water predictions, I have to convert everything to moles first. Now, you're not always going to be given moles, and you're not always going to want the answer in moles. But the only way you can convert from one thing to another, one substance to another, one compound to another, is using that molar conversion. And like I said, sometimes you're working with grams. And I know you guys from chapter 10, when we did our molar conversion problems, you did lots of converting from grams to moles and moles to grams, so you should be proficient with that. If you need to refer back to chapter 10, you can do that. If you want to look back at the diagram that you were given on molar conversions, you can do that. But just know, for example, if you start with something in grams, your first step is to get it to moles. You have to convert it to moles first. So that means looking at the periodic table, finding that molar mass. If I stopped right here, I would be simply converting my 25 grams of hydrogen to moles, right? But of course, that's not what I want, but that has to be my first step. And then I can use that molar conversion, what we've been doing all along, and that will give me my answer in moles. You can imagine if I wanted my answer in grams, I would need one more conversion factor because I'd have to go from moles of water to grams of water. So I would need that additional conversion factor that had the molar mass in grams of water over 1 mole of water, so that moles of water would cancel out. So I hope this is helpful. I will provide, I'll try to provide an answer key for you guys for tomorrow for the worksheet that you're given today. And maybe we can, go over a couple of those problems.